Welcome to Khetz tutorials, and in this video I'll be doing question 54 from 1.5 exercises in James Stewart calculus. So you're asked to solve for x, and let's start with the first one. This one looks a bit weird, but we're still going to apply what we know. If you raise a ln as a power of e, then whatever its argument is, so we're going to raise both sides as a power of e. Whatever its argument is, basically come down. So that ln x will now come down here. On this side we have an e. Then we want to find x. So we need to extract it from its position. And to do that, once again, we're going to raise this as a power of e so that we get that x that we want. On this side, we're just going to raise the e to the power e. On this side, we're going to take that x down because we've raised ln as a power of x, as a power of e. So we now have x equals to e to the power e. And that is your answer for the first one. Moving on to the second one. Here's what we can do. We can start off with dividing both sides by e to the power bx. So if we divide both sides by e to the power bx, these cancel out on this side, and you're just left with c. Okay, then using the rules of exponents, since these bases are the same, they're both e, so you can take this bx up by subtracting it, and you only have a single e. So if you have a variable, let's say x to the power 2 divided by x to the power 3, it's x to the power the one at the top minus the one at the bottom. That's the rule which I used. Now that we have this, we're going to go back to our log rules. We want to take this down because we're solving for x. And to take it down, we're going to find the ln of both sides. If you find the ln of this side, so the ln of both sides, on this side, that will come down because the ln of an e takes the power down. So you have ax minus bx equals to the ln of c. Then here, we can factor out the x because it's common. So you have a minus b equals to the ln of c. Since we're solving for x, let's isolate it by dividing both sides by a minus b. And we now have a value for x.